World War II taught the world some harsh but vital lessons. This was especially true for nations that loudly proclaimed their neutrality, backing up that status with dozens of international treaties. The main takeaway was pretty simple. During a full-scale war, you have to be ready to defend your neutrality by force of arms. To pull that off, you either have to join a side, formally or practically, or you must build up a truly formidable defense industry of your own. Of course, that last option is completely out of the question without a highly developed military-industrial complex. And that second path is exactly the one neutral Sweden chose, starting in the mid-1940s. Long before World War II even broke out, the Swedish government and the leadership of the Swedish Air Force made a strategic decision. They decided to equip their squadrons strictly with homegrown fighters designed by Swedish engineers, or, as a fallback, build proven foreign designs under license. The Swedes had always placed a high priority on building a genuinely capable air force, and this strategy paid off during the turbulent war years. To see just how seriously Sweden took its air power, consider this detail. The Swedish army relied heavily on a cadre system, essentially skeleton units acting as training depots that would only expand to full strength in the event of a general mobilization. On the other hand, their flying squadrons were fully manned by career professionals. They were kept on constant combat alert and could take to the skies at a moment's notice. All this time, Swedish aircraft designers were working hard to create their own advanced, highly capable fighter. By the midpoint of the war, it was abundantly clear to aviation experts everywhere the future of military aviation belonged to the jet engine. The Swedish Air Force realized they needed to stop wasting time on piston engine designs that were quickly becoming obsolete. They pivoted, pouring all their manpower and resources into this promising new jet technology. On a very tight schedule, the Swedish company Flygmotor managed to develop a prototype jet engine featuring a centrifugal compressor. Meanwhile, another company, STAL, came up with their own design utilizing an axial compressor. The plan was to power a completely new aircraft with one of these brand new engines. This was an ambitious project given the working designation JXR. But turning that concept into reality was a different story. It quickly became obvious that Sweden lacked the hands-on experience needed for jet engines, as well as the advanced metallurgy required for high-temperature alloys. Based on their projections, they would not actually be able to build these highly anticipated engines until 1952 or 1953. For the Air Force, waiting that long was completely unacceptable. On paper, the projected performance of the new JXR fighter would have put it nearly 5 years ahead, outpacing an iconic early American jet like the Lockheed P-80 Shooting Star. At the same time, airframes like the Saab J29 were quickly becoming obsolete. This model was entering service in both piston and jet-powered variants, but it simply could not keep up with the strict demands of the early jet age. Because of this, in 1946, the Swedish government had to scramble for a stopgap solution. They turned to foreign markets and procured 90 legendary P-51D Mustang fighters. They also bought 60 Mosquito NF-19 night fighters and 70 high-speed Spitfire PR-19 photo reconnaissance aircraft. This stopgap measure successfully kept the Swedish Air Force combat ready, allowing them to hold the line right up until their own domestically built jets finally started reaching the squadrons. Ever since 1936, turbojet engine development in Sweden had been spearheaded by the brilliant engineer Alf Lysholm, who was working for the renowned Bofors company at the time. In the early 40s, he was promoted to chief engineer at Svenska Flygmotor. Then, in 1946, another major firm, Svenska Turbinfabriks, joined forces with them. On top of their own research, the Swedes had a major ace up their sleeve. Swedish engineers got their hands on highly detailed intelligence regarding secret German jet technology, thanks to their close ties with Daimler-Benz. At the time, the Germans were officially supplying Sweden with DB601 aircraft engines and helping them set up licensed production at domestic plants. Swedish observers were watching the war from their neutral borders, and even witnessed dogfights involving the brand-new German Me-262 jet fighters firsthand. So, in early 1945, a team of Saab engineers led by Lars Bresing launched the R101 project. This was a lightweight, straight-wing jet fighter that bore a striking resemblance to the American P-80 Shooting Star. The R101 design was nearing completion when new developments suddenly changed the game. Naturally, unlike the Allies, Sweden did not have its own technical intelligence teams eagerly picking apart the scientific legacy of a defeated Germany. However, many German engineers scattered across the globe after the surrender, maintaining excellent relationships with their Swedish colleagues. As a result, in November 1945, under a veil of absolute secrecy, a Swedish engineer in Switzerland received swept-wing aerodynamic test data from German exiles. This data was incredibly promising. By the end of the year, Lars Breising started working on a completely new design, the R-1001 fighter, featuring a 25-degree swept wing. At the same time, they had to tackle another major hurdle, finding a reliable jet engine. Right after the war, Britain was the undisputed king of jet engine development. But despite winning, their economy was wrecked, and they desperately needed export revenue. Because of this, cutting-edge jet engines and aircraft became some of their top exports. It is a fascinating historical paradox. Even after Winston Churchill gave his famous Iron Curtain speech, which essentially kicked off the Cold War, the Soviet Union legally purchased the latest British Nini and Derwent jet engines in 1948. What is more, they even acquired the production licenses, something the British would later bitterly regret. The pragmatic Swedes also decided to take advantage of this opportunity. They halted their own engine development, and a domestic firm bought a license from the British company de Havilland to produce the Goblin engine. These engines were later fitted to J-21 fighters, transforming them into the jet-powered J-21R variant. Around the same time, in 1946, Sweden purchased 70 de Havilland Vampire jet fighter bombers. 2 years later, they ordered another 200 of the same aircraft. These fighters were primarily used to train Swedish pilots, preparing them to transition to domestically designed jet aircraft. Meanwhile, the R-1001 fighter project was moving forward rapidly. Initially, they planned to install the Goblin engine. However, in late 1945, Lars Breising visited the de Havilland factory, where he saw a new, much more powerful design. It was the Ghost engine, producing around 4,850 pounds of thrust. Before long, they began completely redesigning the R-1001 to accommodate this massive power plant. Interestingly, Saab managed to go straight from design to production-ready prototypes, skipping the typical intermediate stages. The Swedish engineers faced an uphill battle, lacking access to the theoretical data other nations were gathering through extensive testing. Despite these hurdles, their aircraft, later designated the J29, made history. It became the first production-swept wing fighter designed entirely in Europe. The new de Havilland Ghost engine featured a centrifugal compressor and had a massive diameter. Because of this, the J29 was essentially built entirely around the engine. As a result, the fuselage started with a narrow nose intake and bulged noticeably in the middle, housing the power plant exactly at the center of gravity of the aircraft. Thanks to its distinct, rounded contours, the fighter earned the nickname Tunnan, which translates from Swedish as the barrel. To keep the airframe strong but easy to maintain, engineers utilized a stressed skin design, where the outer skin carried much of the structural load. The cockpit sat directly on top of the large intake duct feeding air to the engine. The tail unit was mounted on a relatively thin boom extending just above the exhaust nozzle. Interestingly, the designers didn't reinvent the wheel when it came to the cockpit pressurization system and the ejection seat. These were carried over directly from the earlier Saab J29R. The main backbone of the entire airframe was the central intake duct itself, heavily reinforced with robust frames and bulkheads. This solid foundation served as the mounting point for all critical components, including the wings, internal systems, and the landing gear. The fuselage was visually and structurally divided into 3 sections. In the front, just ahead of the pilot, a massive armor plate was installed for protection. The center section housed the cockpit and the turbojet, blending smoothly into the tail section. They were connected by 4 heavy-duty attachment points just ahead of the antenna mount. It featured a relatively high-mounted, all-moving horizontal stabilizer. The pilot could electrically trim its angle in flight from +1 to -6 degrees. All of the landing gear and fuel tanks were housed entirely within the fuselage. The lower aft fuselage was deliberately kept short. This allowed them to significantly shorten the exhaust pipe, avoiding unnecessary thrust loss. But the real highlight of the design was the thin wing mounted high on the fuselage. They made the skin as aerodynamically clean as possible by using flush rivets. However, when engineers began wind tunnel testing, it became clear that a wing with this shape would suffer from severe stability issues. At the time, this problem was usually solved simply by reducing the wing sweep. Instead, the designers leaned on captured German aerodynamic research and found a clever workaround, a compound sweep. A quarter of the way out from the center line, the sweep angle was 25 degrees. From there, it sharply increased to 43 degrees outboard. The total wing area was about 258 square feet, resulting in a wing loading of roughly 49 pounds per square foot. Because the wing profile was so thin, there simply was not enough room for the main landing gear struts, meaning they had to retract directly into the fuselage. The Swedish military wanted the Saab J29 fighter to be able to operate from short, unpaved airstrips without a hitch. So engineers added automatic slats to the leading edge of the wing. They deployed in sync with the flaps, making low-speed handling much easier. As they continued to refine the aircraft, the wing underwent further changes. To make the fighter more responsive, Chief Designer Lars Breising equipped it with flaperons, control surfaces that combine the functions of flaps and ailerons, spanning the entire trailing edge of the wing. These were driven by powerful hydraulic actuators, taking the physical strain right off the pilot. The fuselage shape is an interesting detail. Originally, the wing roots were designed to blend smoothly into a round body. However, engineers ended up slightly pinching the fuselage sides. Even before the famous area rule for reducing transonic drag was officially defined, Saab designers were intuitively applying its principles. To test how this innovative swept wing would actually perform in the air, they first mounted a scaled-down version on a small propeller-driven Saab 91 Saphir testbed. This modified aircraft took to the skies for its first flight on April 28, 1946. For the final version of the jet fighter, they settled on the license-built Ghost 45, or RM2 engine. It gave the aircraft plenty of thrust, but it had a massive cross-section. Because of its sheer size, the designers were forced to make the fuselage short and bulky. Aerodynamically, this was less than ideal, but that barrel-like fuselage came with some major advantages. There was enough room inside to pack a serious arsenal. They mounted 4 powerful 20mm Bofors aircraft cannons right under the front air intake. It also left plenty of room for large internal fuel tanks. This was absolutely crucial, as early jet engines guzzled fuel at an alarming rate. In the fall of 1946, the ambitious R-1001 project was finally presented to the military high command. The Air Force gave the green light to build the first 3 prototypes of this brand new fighter, which later earned the designation J29. Around the same time, the developers showed the military a full-scale mock-up of the nose section housing the cockpit. Work kicked into high gear. Under the watchful eye of lead specialist Bengt Olau, the engineers began carefully planning the layout of all flight instruments and control systems. Interestingly, while putting together the first 3 aircraft, the designers immediately laid the groundwork for a 4th prototype as well. The entire development process went incredibly smoothly without any major hiccups or delays. Then came the historic day, September 1st, 1948. Experienced British test pilot Lieutenant Colonel Robert Moore took the controls. He wasn't chosen by chance. He was specifically brought in for his valuable experience flying swept-wing aircraft. The Swedish engineers really outdid themselves, literally packing this first prototype with all sorts of telemetry and test equipment. Sweden simply did not have the budget to build dedicated, purely experimental testbeds. To measure the slightest structural loads and airframe stresses, they wired the jet with around 60 sensors and flight recorders. And to make the demanding job of the pilot as easy as possible, the cockpit was equipped with an onboard voice recorder, quite possibly a first in world aviation history. All these sensors were linked into a single telemetry system capable of capturing around 500 different data points simultaneously. And so the moment of truth arrived. The first J29 prototype took to the skies for a 30-minute test flight. The main goal was to test the automatic wing slats, checking how well the aircraft handled and responded to the controls under various conditions. It didn't go without a few surprises. A hydraulic system failure prevented the main landing gear from retracting fully, keeping Moore from pushing the fighter to its max speed. Still, that setback didn't diminish the overall impression. Moore gave the fighter incredibly high marks, specifically praising its responsiveness and excellent maneuverability. The heart of this aircraft was a de Havilland Ghost jet engine producing around 4,400 pounds of thrust. Initially, the flaps and slats were interconnected to deploy together, helping drop the landing speed by about 5 knots. But military leadership wanted to ditch such a complex system, so the wing mechanization was simplified on the second prototype. To make the airplane easier to handle during landing, the flap deployment angle was restricted to 30 degrees. In early 1949, 2 new prototypes joined the test program. While the very first airplane was strictly a flying testbed to prove basic airworthiness, these 2 were fully equipped with their weapon systems and full military avionics. The second J29 was heavily used to finalize the fighter's flight envelope and tactical specs, while the third became a dedicated weapons testbed to evaluate the internal cannons and external ordnance. As testing continued, pushing the first prototype toward 480 knots started revealing a serious design flaw. The tail section experienced severe vibrations, placing dangerous loads on the entire airframe. Engineers scrambled for a solution, heavily reinforcing the rear fuselage structure. They completely reworked the aerodynamics of the tail to smooth the airflow and redesigned the transition from the exhaust nozzle to the aft fuselage. Their main goal was to permanently eliminate flutter, a deadly phenomenon where high-speed airflow causes vibrations severe enough to literally tear an aircraft apart in flight. All of these vital modifications were immediately incorporated into the fourth prototype. For all intents and purposes, this fourth aircraft was ready for mass production. In July 1950, it successfully entered its acceptance trials. This was a truly massive achievement for Sweden, especially considering that right up until the start of the Second World War, its aviation industry barely registered on the global stage. When the first 16 production fighters rolled off the assembly line, they featured speed brakes mounted directly on the wings. But test flights revealed that deploying these brakes caused severe buffeting in the flight controls. The design team quickly relocated the speed brakes from the wings to the underside of the fuselage, just forward of the main gear doors, tweaking their aerodynamic profile to improve stability. On top of that, the upgraded production aircraft got an improved version of the Ghost engine, now putting out roughly 5,000 pounds of thrust. Ultimately, it was that fourth prototype that became the definitive baseline for mass production. By that point, absolutely every major flaw from the earlier test frames had been ironed out. The history of this design turned out to be an incredible success story. Following the 4 initial Saab J29 prototypes built in the late 40s, full-scale production kicked into gear. Between 1951 and 1965, the Swedes built more than 220 of the base model J29A. A bit later, an even larger batch rolled out of the factory, including over 360 of the upgraded J29B variant. This aircraft served as the backbone of the Swedish Air Force for years to come. Flight testing generally went smoothly. However, as the airspeed pushed toward 485 knots, pilots reported that the aircraft started wandering and the controls became sluggish. To fix this, engineers made a few modifications to the production airframes. They reshaped the transition from the fuselage to the tail section, tweaked the base of the empennage, and reinforced the overall structure to safely handle the higher aerodynamic loads. In its final refined form, the aircraft was designated the J29A. By May 1951, the fighter officially entered service. Pilots from the Air Wing based in Norrköping were the first to put the new fighter to the test under operational conditions. Production moved at a brisk pace. Between 1951 and 1953, a total of 224 J29s rolled off the assembly line. Before long, the fighters started arriving in numbers at other units as well, assigned to squadrons bearing the names of historical provinces like Kalmar and Uppland. However, the pilots themselves weren't exactly enthusiastic about the new jet at first. Thanks to its unique, stubby appearance, the fighter quickly earned the nickname the Flying Barrel among the crews. On top of that, pilots found the fast new jet incredibly difficult to master. Commanders urgently set up special transition training courses, having pilots train extensively on SK-28s, the Swedish designation for the 2-seat de Havilland Vampire. But the biggest complaint was the jet's extremely limited fuel capacity. Engineers got to work, soon rolling out the updated J29B. Designers cleverly managed to squeeze additional fuel tanks into the inner wing sections. These reinforced rubber bladders held about 185 gallons of fuel, effectively doubling the aircraft's combat radius compared to the J29A. They also introduced external drop tanks mounting under the wings, coming in 105-gallon and 119-gallon versions. This massive increase in fuel load gave the High Command a lot more flexibility. Now, the J29B could be used effectively not just as a standard fighter, but as a fighter-bomber capable of delivering heavy strikes on ground targets deep behind enemy territory. Thanks to this, the Swedish Air Force finally modernized its strike fleet, which in the mid-50s was still relying on obsolete J-21R and British Vampire jets. To make the new aircraft even more effective at taking out ground targets, a portion of the J-29B fleet was fitted with special underwing pylons capable of carrying up to 16 145mm unguided rockets from Bofors. In this heavy-hitting strike configuration, the aircraft received a new designation, the A-29B. The first prototype of the upgraded J-29B took flight in March 1953. Just 2 months later, deliveries of production aircraft began to various fighter wings, including the Skåne wing. Over the next 2 years, the A-29B entered service with the Västergötland and Skaraborg attack squadrons. Meanwhile, the older J-21Rs, Vampires, and early J-29As in those units were gradually retired, either scrapped or handed over to training centers. Production of the J-29B ramped up at a frantic pace. It got to the point where the factory airfield in Linköping was completely packed with brand new aircraft sitting on the tarmac just waiting for their maiden test flights. In total, between 1953 and 1955, 361 aircraft of the J and A-29B variants rolled off the assembly line. The Tunnan even managed to grab a piece of international aviation history. On May 6, 1954, flying a production J-29B, Swedish Air Force Captain Knut Westerlund set a world speed record. He flew a 310-mile closed circuit at an average speed of 607 miles per hour, shattering the previous 2-year-old record held by the famous North American F-86 Sabre. Typically, the entire bomb load was carried on underwing pylons. But to free up these hardpoints specifically for ordnance, engineers redesigned practically the entire fuel system, eliminating the need for external drop tanks on standard missions. By fitting more fuel inside the fuselage and wings, the internal fuel capacity jumped to a massive 555 gallons, up from the original 378. On those freed-up hardpoints, the aircraft could mount a truly massive weapons payload, standard high-explosive or napalm bombs, or a full suite of unguided rockets in their native metric calibers. 75mm, 100mm, 145mm, 150mm, and 180mm. Even after loading up all this ordnance, there was still room on the pylons for external drop tanks if needed for longer-range missions. Fully fueled and armed, the maximum takeoff weight increased significantly, creating a serious problem. Sweden had a strict doctrine requiring all military aircraft to have excellent short-field takeoff and landing capabilities, allowing them to operate from dispersed road bases during wartime. The overloaded A-29B needed way too much runway. To solve this, designers started developing special solid-fuel JATO boosters mounted on the aft fuselage right behind the wings. Immediately after takeoff, pilots would simply jettison the spent casings. While JATO testing went well, the ultimate solution was the upgrade to the RM2B engine. Engineers integrated an afterburner, drastically increasing thrust and shortening the takeoff roll without complex airframe modifications. To test fly the upgraded engine, they installed it on a brand new A-29B straight off the assembly line. Over the next few years, Saab rolled out over 350 of these aircraft to frontline squadrons. Visually, the tail section was extended further back, and the engine exhaust nozzle was noticeably wider compared to the older J29A. The outstanding flight performance inspired Saab's engineers to develop a high-speed photo reconnaissance variant. At first, the concept was to just install a small camera in the nose, but after consulting with experienced Air Force commanders, Lars Breising and his team completely redesigned the nose section. They stripped out the heavy cannons and replaced them with a specialized bay housing 5 cameras. Early on, these cameras were protected by doors that opened downward and forward, acting as unwanted speed brakes in flight and creating massive drag, forcing a redesign. The most interesting setup was the left side camera, which used special infrared film to capture crystal clear shots through thick cloud cover. Since a single roll of this film cost a fortune, around $1,000 at the time, it was only loaded into that specific camera. Because this recon gear took up way more space than the standard cannons, you can easily spot any S-29C Recon variant by the distinct, boxy fairings under its nose. The S-29C Recon variant made history as the very first Swedish aircraft equipped with a radar warning receiver, or RWR. Its antenna was neatly tucked under the aft fuselage, while an electronic countermeasure system for jamming enemy radar was housed inside the tail. A few jets were also fitted with navigation radars mounted under the belly. The first production S-29C took to the skies in the summer of 1953, with just over 70 built in total. Interestingly, this Recon variant ended up being the very last production model in the entire J29 family, closing its run in the spring of 1956. During routine operations, crews discovered an unexpected advantage. If the pilot fully opened the camera doors, deployed the speed brakes, and dropped the flaps, the S-29C could dive at an almost vertical angle, something the standard fighters physically could not pull off. Thanks to these aircraft, the government generated incredibly accurate maps of the entire country. In the spring of 1955, 2 Swedish pilots, Hans Nide and Birger Eriksson, set an impressive world record in the S-29C, flying a 620-mile closed circuit at an average speed of 560 miles per hour. Despite these records, the Swedish Air Force knew perfectly well that by the mid-50s, the J-29A and J-29B were becoming obsolete. Back in the late 40s, Saab had already started developing an entirely new generation of jets, including the Saab 32 Lansen attack fighter and the high-speed Saab 35 Draken interceptor, expected to enter service around 1955 and 1956. To bolster their air power, the Swedes also ordered over 100 Hawker Hunter F-4 fighters from Great Britain in 1954. Designated J-34. However, the aging J-29 series would have to remain the backbone of the Air Force right up until the early 60s. They urgently needed to upgrade their existing fleet, with top speed as the #1 priority. Engineers tackled the problem from 2 directions. In late 1953, the J-29E prototype took to the skies. Essentially a standard production J-29B, it featured a completely new wing that was slightly thinner and featured a distinct leading-edge extension pilots nicknamed the Dogtooth. Upgraded flight controls made the aircraft much more stable, allowing it to comfortably maneuver at speeds up to Mach 0.9. Plans to convert most older fighters to this standard changed when a local company developed an effective afterburner system for the RM2 engine. Originally designed for the A-32 Lansen, this afterburner development was redirected to the J-29 when the British offered a more powerful Rolls-Royce Avon engine for the Lansen instead. By the summer of 1953, the first upgraded RM2B engine with an afterburner began test stand runs. The next step was combining these technologies. Saab introduced a simple but effective aerodynamic solution. The leading-edge Dogtooth combined with small wing fences completely transformed the aircraft's handling and significantly increased wing lift. The jet's critical Mach number jumped from Mach 0.86 to Mach 0.89, making it a much more capable adversary. The experimental J-29E prototype with the new wing was still flying with the old non-afterburning RM2 engine. Only 29 of these were built before being upgraded again. Then, in the spring of 1954, the fully fledged J-29F prototype made its maiden flight. Boasting the innovative wing and the powerful new RM2B engine pushing 6,500 pounds of thrust, this fighter could accelerate to an impressive Mach 0.93 in a steep dive. The budget-conscious Swedes decided to simply upgrade their existing fleet to the J-29F standard rather than build new aircraft from scratch. Over 200 early model fighters were modernized at the factory, while almost 100 more had the new wings installed at operational airbases. Pretty soon, the S-29C reconnaissance jets also received the updated dogtooth wing. In total, more than 300 aircraft went through this massive modernization program. In late 1955, the J-29F's firepower got a serious boost. Dedicated hardpoints were installed under the wings to carry RB-24 heat-seeking missiles, the famous American AIM-9 Sidewinders, built under license in Sweden. A few J-29Fs were also converted for training with target towing gear. These upgraded jets entered service in large numbers across various fighter wings, providing a solid air defense network. These aircraft served faithfully in frontline squadrons right up until the mid-1960s, receiving newer avionics over time. As technology marched on, the J-29 was gradually replaced by the J-32 Lansen and J-35 Draken. Older airframes met varied fates. Some were scrapped, others went to training centers, and some ended up as hard targets on bombing ranges. A good number, especially the S-29C Recon variants, were converted into aerial target tugs. In 1967, the legendary Tunnans flew their final combat training missions, serving until 1975 before being completely replaced. Throughout their entire operational life, the fleet never suffered a single major systemic flaw. Pilots absolutely loved their excellent handling, maneuverability, and rapid climb rate, while ground crews respected how incredibly easy they were to maintain. The J-29F variants served the longest of any Tunnan, staying in service until 1977, though strictly as target tugs after 1968. The weapons payload was genuinely impressive. The primary armament was 4 20mm cannons, each with 180 rounds. For rockets, it could carry 12 75mm air-to-air rockets, 8 80mm anti-armor rockets, or anywhere from 8 to 14 heavier 145mm or 150mm anti-tank rockets, weighing around 100 pounds each. For anti-shipping strikes, it carried 2 or 4 heavy 180mm rockets, weighing about 275 pounds each. It could also drop 105-gallon or 132-gallon napalm canisters, and carried 2 AIM-9 Sidewinder missiles for dogfighting. Back in 1950, there were plans to build 20 SK-29 two-seat trainers, but Saab's production lines were so backed up that the project never left the drawing board. It's a shame, as they could have saved a lot of inexperienced pilots. Out of the 661 airframes produced, over 200 were lost in mishaps, tragically costing 99 pilots their lives. Ambitious plans to fit them with radar for all-weather interception also never materialized. However, the J-29 holds a truly unique place in Swedish aviation history as the only Swedish Air Force combat aircraft to ever see action in an armed conflict far from home. This unfolded in the early 60s in the Congo. Following independence in 1961, a bloody rebellion broke out, led by a self-proclaimed general named Chombe, who seized the Katanga province. Chombe put together his own air force, built around Foga Magister jet trainers and light Dornier Do-28 transports hastily converted into makeshift bombers flown by foreign mercenaries. When rebel forces brazenly shot down unarmed UN transports, the UN had no way to strike back. Eventually, Secretary General U Thant authorized a dedicated combat air wing in the Congo, which included Indian Canberra bombers, Italian C-119 transports, and Swedish J-29B fighter bombers. Just 5 days after receiving orders, 5 Swedish jets touched down in the Congolese capital. On December 6, 1961, following another rebel bombing, Swedish J-29Bs teamed up with Canberra bombers for a massive 2-day operation. They relentlessly pounded enemy airfields in Katanga, wiping out dumps and convoys, and destroying a Magister and 3 Do-28s on the ground. UN forces took control of Kamina Air Base, where the J-29Bs relocated. In November 1962, they were reinforced by 2 S-29C Recon aircraft flown in by USAF transports, followed by 4 more J-29Bs in December. The Tunnans proved extremely rugged, delivering excellent performance despite the grueling tropical climate. On December 12, 1962, they completely leveled Chombe's residence in Elizabethville, forcing him to flee and effectively crushing the rebellion. Throughout the deployment, only 2 J-29Bs were lost to ground fire and operational accidents, proving the high quality of Sweden's first jet fighter to military experts worldwide. The J-29 Tunnans also went down in history as the first Swedish combat aircraft officially exported. In 1961, neutral Austria selected retired Swedish J-29Fs over the Soviet MiG-17F and American F-86 Sabre. Austria initially bought 15 aircraft, followed by 15 more in late 1961, delivered in 1963 after a Saab overhaul. 12 of these were specially upgraded with 3 Vinten reconnaissance cameras in place of the portside cannons. The J-29F served the Austrian Air Force for 11 years until July 1972, replaced by the Saab 105. One dramatic incident occurred in October 1964, when 2 Austrian J-29Fs flying in heavy fog accidentally pushed deep into Czechoslovak airspace. Intercepted by MiGs, the disoriented jets made a hard emergency landing in a field near Prague. Both pilots survived, but the smashed Tunnans had to be scrapped. But the story didn't end there. Aviation enthusiasts restored a retired J-29F, which had logged 1,195 flight hours, to airworthy condition. Nicknamed Yellow Rudolph, it took to the skies once again on July 11, 1995, and continues to thrill crowds as a regular performer at air shows around the world.